welcome Ashot Harutyunyan from Armenia.
Thank you. I would say thanks to organizers for inviting me. My name is Ashot. Sorry. My name is Ashot. I work for a company called Develandu. I'm a AWS certified developer. Develandu is artificial intelligence innovation lab, very specialized in building early stage companies while leveraging AI and machine learning techniques. We have operations in the US, in Munich, Germany, and the engineering team is located in the beautiful city of Yerevan. So one of our successful startups is Skyla. Skyla is a real-time threat detection system that works on top of CCTV cameras and drones. We have customers in the US, in Latin America, as well as in Middle East. So today's topic is about complete automation of software delivery. And I've been spending lots of time looking at continuous integration, continuous delivery, cloud automation, infrastructure automation, automated testing, and all of those sorts of things. And realized that most of the times architectures of the system themselves making it hard to ship the software frequently. So back in 2018, when I was in a business trip in Amsterdam, I came back on October last year, and the management immediately dispatched me off to work for a German client. They had a huge HR operating system which provides lots of good features for HR managers to control and automate the hiring, firing, vocation, salary processes, and more. So a few years it's rolled on, and the team is currently working on release 2. When I say release 2, it's like imagine a huge bucket of changes and features that should be delivered at the end of the development. So there was also that awareness of what we sometimes call technical debt building up. When you realize that you should do some kind of breaking changes which are going to be impactful. So therefore there was a decision to cut off the current state of the mainline and have all the team working on those breaking changes while the release 2 people were delivering real value to the customers. And 6 people from our side joined the project, and they started working on those breaking changes, while the release 2 people, the core team of the software, was too busy delivering real value to the customers. And during the development of those 2 releases, lots of good stuff has been done. After the project goes for a while, you realize that you refactor some code bases, you come up with the new optimizations and more. And finally, release people said, we kind of like done everything you want, and we want to make the release 3 branch the newer live version of the production of the system. And therefore, to make it possible, we should bring the changes from R2 to R3 to make a live production release of the software. And that's going to be easy, right? You sort of merge the many months of work done by 2 separate teams inside a single branch. And that's going to be absolutely easy, right? Turns out not so much, and I arrived at the moment as the process was happening. So in our very first meeting, the very first question I've been asked is, okay, we have a very exciting proposition to you. How would you like to join R2 and R3 branches together? And only the correct answer was that time, yeah, that's going to be painful. And this scarred myself and many other people working on the project and made us to really go back to the history of continuous integration and continuous delivery to really practice that original principles. So when I tell these kind of stories to people, they always ask me, why didn't you do a continuous integration to avoid those big change mergers and to avoid get fast feedback? And the reality was we were doing continuous integration. So let's understand first how that works. You have your laptop, you create some code, and most probably there is some kind of version control system which you use to commit your changes and push your changes up to the remote repository. And could be Git in our case. And on top of that, there is some kind of CI tool which will pick up your commit and make sure your commit integrates with the last commit, the existing common mainland. Could be GoCD, it's not visible, but it's with GoCD or Jenkins or AWS code, it doesn't really matter. And then it will do a compile step and a verification step, and then finally provide some feedback whether or not your change is working. So here I'm working my code, I'm checking in, I get a feedback. My colleague does likewise, she's checking in, she's getting a feedback, and she makes sure that her changes integrate with my changes. And the integration is not only I don't have conflicts in the version control system, but it also proves that the system still behaves the same way as it was before I check in. Now, if I check in and I break the build, that becomes the top priority of the team to fix the broken build. Because if the build is broken, nobody else can check in until the build is fixed. This is the rule, the cardinal rule of continuous integration, which says the integration should happen daily to avoid big merges and to get fast feedback. But you also have in mind that you should check in frequently, right? Because if you are working on a feature many days and finally want to check in, you will end up with the same big merge problem. That's the goal. That's what continuous integration is. It says the integration should happen daily. But the reality again was with German clients we were doing continuous integration, but with, in a quite different manner. We had released 2 people working on their changes and they were checking it daily. And they had their CI build. And we had also our release 3 people working on their changes and they were checking it daily and they had also their CI build. But the problem is the final merge of those 2 branches because it should happen someday. And but the idea again says the integration should happen daily to avoid big merges and to get fast feedback. But this is good, but the idea of constant integration butts up against another problem, namely not all of your work can be done in a single day. Even if you think it could be, something is going to happen, right? You will be called in a meeting, in a football game, or you can get sick someday. Or finally, you want to save your changes somewhere safe if something bad happens, right? So there are a bunch of ways that we can handle this situation. Option number 1, simply don't check it. And we really like this because, but we were doing this a lot, right? If we are working on a feature more than a day, or maybe your machine broke, or anyway you want to keep your changes somewhere safe, right? Something bad happens. So we don't like this option, and we throw this away. Option number 2, make a branch. Isolate yourself from the rest of the team, and branches provides a good isolation for the developers to work on the features that are not quite ready to go into production. How's that work? Here I'm working my code. I do realize that my changes will take a while, and I create a branch from the master to the trunk, and I start pushing it locally on my branch. And my colleague does likewise. She creates a branch and she starts pushing on her branch. And when we finish, we will merge that branches into trunk. That's how feature branches work. When you create a branch every time you want to implement a feature. And on top of our branches, we have CI builds, which will help us to understand whether or not our changes are working. But the issue here is still have the same problem of release 2 and release 3 branches. Because if you are working on your, you are still checking in on your branch, not to everybody else's branch. you're still declaring that integration inside the deployable unit. Okay, so I'm not clearly a big fan of feature branches. So what was the other option? We want to integrate often. We don't want branches, but we still want to check in. So how's that work? Because if my feature is not finished, how can I check in? But that's the idea behind the trunk-based development, which is everybody integrates into the trunk. Trunk could be Git in our case, master in Git, for example. And everybody is there, they work on their changes, and they make sure their changes integrate with everybody else's changes. We get fast feedback when the integration works, and we avoid big giant merges. Of course, we have some other activities like compilation and static analysis, automated testing, and all of those sorts of things. But again, we still don't have that answer of how finished features, because not all of our work can be done in a single day, right? Or more often, we are working on the existing functionality. Not always we implement a brand new functionality. We normally should have some technique which will handle this kind of situation. And that normally does feature toggles. Feature toggles are a way of hiding partially implemented features inside running inside the existing system. So a very simple example how feature toggles might work. Let's consider a website. I'm working on a super brand new widget which is going to display a very important information on the bottom of my e-commerce website. So it's not quite finished because I have to modify the font sizes, I have to fix some bugs and so on. And what I do, I actually hide that widget. It's not available on the production side, but there is a code configuration file which specifies whether or not my widget is visible. So this activity can be done either build time or run time when your system is running. And you can also use command line flags or toggling services. But the idea is the code is tested, it's integrated, it's inside the single branch, but it's not visible on the production environment. But a lot of time, of course, we are changing existing functionalities, right? Not more often creating a brand new widgets. So let's talk about how that might work. And let's consider an example. This is an example from Scala. Early days of Scala, we used to have a software for called Scala Connector. It was designed specially for the people who want to try the system and on their local machines. The Scala Connector was designed for the people who want to use local IP cameras or embedded web cameras to try the system and understand how that works. It was designed to serve the video stream from the local networks to the hosted server on AWS cloud. And when we first started, this was a really good way to provide the people the understanding of how the software works. And as it grew, we realized that we should change the database that was storing the metadata to handle the large scale and to make it easier to handle failures. And the problem was we still wanted to keep shipping new features, and we wanted to make the newest version of the software available for the downloads every 2 weeks. And this change was taking a while, and team had to work on those new functionality almost several weeks, concentrated weeks of work. So that was the goal, and practicing continuous delivery and continuous integration for a downloadable product is a quite difficult challenge. So we said, okay, we're going to send Scala live and have it running proper database, which will help us to handle failures and make it easier to handle large scale. So how do we solve this? We add a brand new version of that functionality. we come up with a work in progress generic database implementation. As this is in progress, we want to have some point where we can toggle that behavior to understand whether it's working or not. So therefore, you add an abstraction layer on top of your two functionalities to have a possibility to toggle that behavior runtime. And this will help you to try the new functionality, make sure it's working, and when you're happy, roll that change out. And you can also delete the old implementation. And you can also delete the abstraction layer if you want to. So rather than using feature branches where all of my changing behaviors are, where all of my coexisting functionalities are, I'm using everything on the same place at the same time. And this pattern called branch by abstraction. So rather than branching repository layers, I'm branching my source code layer on the same version of the code. And most of the people don't like this because it requires you to refactor the source code to an abstraction code. And my view is always, if you can't refactor your code to an abstraction point, you've got different problems. So some important rules to remember while you are using feature toggles. Use them as few places as possible, because it may become a nightmare, right, to manage all of those blocks. Remove them once you're done. When you are no longer need a feature flag, just remove it to avoid confusion later. Use a set of names for every environment, so you can understand easily what environment you are toggling. And you can also group toggles to understand which of them work on runtime or build time. So be very, very careful while you are using these feature flags. You don't want a lot. You remove them once you're done. Use them as many places as possible, and that will be okay. So some side benefits of feature toggles. It's easy to roll back a certain feature if it contains a bug or misbehavior. It's easy to do A/B testing when you turn the feature on and start monitoring and understanding how that works. And you get a fast feedback because you can just enable the feature and start monitoring and understand how it behaves. And the canary releasing make it easier with the feature toggles. If you don't know what is canary releasing, it's a technique when you release the newer version of the software to some subset of your users, and then when it behaves properly, you roll that change out to everyone. So now we have also organizations that provide feature toggling services. Two best of them are Split.io and LaunchDarkly. They provide the ready SDKs for different kinds of programming languages to toggle the behavior, either runtime or build time. I'm sure you will find your programming language. And they provide the central visibility dashboard where you have all of your feature flags and you can manage them, you can add them, and so on. And you can also get some fancy things like location-aware feature flags. When you want to roll some feature to, for example, US customers, you can create a location-aware feature flags, and it will filter the customers based on their IP address. And you also have role management dashboard where you can manage your feature toggles and distribute that into your internal system. And more about trunk-based development, you can read in the trunkbaseddevelopment.com website, and it's dedicated to the topic. And Martin Fleur also has a very good article about feature toggles. So I'm not here to necessarily say that branches are evil. No, especially if you're using Git. Git make it easier for you to create the branches in a safe, in a quick, in a cheap way than we had before using with traditional version control systems. When you had to create a branch before, like let's say 10 years ago, you had to have a conversation about it. Because normally it was, when you are creating a branch, it was the entire copy of the source that you are creating. But still, Git allows you to have as many branches as you want, even if you have developers, hundreds of developers working on a distributed system, it's still okay to create a branch for every developers as many as they want. Why Git became popular? Because of GitHub, of course. GitHub introduced something called pull requests late in 2008. Pull request, when you want to do a change on a certain repository, on a public repository, you are forked that repository and you get the entire copy of the repository. And you work on your changes, you make sure it's working, and you open a pull request asking the maintainer to have a look and merge that back in. And this proved to fundamentally shift the way of how open source projects was developed. The idea is when you fork the repository, you get the entire copy. You don't need to create branches. You work on your copy, and when you're finished, you are opening a pull request, kindly asking for a maintainer to have a look and merge that back in. If you look in the open source world, there is no such term manual QA. It doesn't exist. There are no complicated branching models, and there are no long-lived branches, because everything is automated and in an easy and efficient way. Then it comes Git flow, because something worth doing complicatedly, right? So this is one of the examples how Git flow might work. I drew this myself, and you have to create a branch every time you work on some change or some new functionality, and you have some restrictions on how you name your branches. For example, if I want to implement a feature, I'm creating a branch out of development, and I name my branch with the prefix feature, dash or slash, or some small description of my feature. I'm working locally on my feature branch, and when I'm happy, I will open a pull request asking the maintainer to have a look and merge that back into development. And this is really complicated comparing to a single line of trunk-based development. And it's very difficult to explain to people how this model works. But most of the people like this, and they even created some tools on top of this model. But nonetheless, the idea of the original idea of pull requests was to protect the repository against untrusted committers. The idea is when I have a public repository on a GitHub, when I want to add my friend to help me developing that repository, I'm adding him as a collaborator because I trust him. I know that he's going to help me, not to destroy my repository. But there are many people who want to work on my repository from the worldwide. Like they want to change something, they want to add something, they want to help developing the software. They can fork the repository, but they can't push directly to the repository. That's the idea. And they will work on their fork safely, and then open a pull request asking me to review and merge that back in. I've seen many small organizations and small teams working on small projects making use of those pull requests and Git flow and feature branches. I was actually thinking, what's the point? If you have untrusted committers committing directly into your repositories, you've got different problems. And let's quickly wrap up what we have learned. Trunk-based development is a source-controlled branching model where developers collaborate on the code in a single branch called trunk. Could be mastering. And resist any pressure to create any long-lived development branches by employing the documented technique. They fork and avoid merge out and do not break the build and live happily ever after. Feature toggles. Feature toggles or feature flags are powerful techniques allowing the team to modify the system behavior without changing the code. Feature toggles can be used to hide, enable, or disable a feature during the runtime of build. requests are powerful mechanisms. When you request someone to review the work that you have done and merge your changes in, pull requests are powerful mechanisms against untrusted committers. Branch by abstraction. Branch by abstraction is a technique for making large-scale changes in the software system in gradual way that allows you to release the system regularly while the change is still in progress. So 3 core rules to remember from this entire story: integrate often, keep your batch size small, and ship your software frequently. That's all. Thank you. I'm sure there are questions. No? Yes, please.
Thank you for the talk. I just want to ask about the toggle enable disabling. How you doing it? Are you providing a new release to customer with enable toggle, or you enable disabling by your side?
Okay. So that depends. If you are working on a large systems, you should think about it initially. You should have every configuration for feature toggling in place when you start working on a new project. If you don't have that implementation for larger systems, you should add to be able to toggle during the subsequent releases. But it's also it's always good to have them in place when you're working on large-scale products. For smaller websites or for smaller products, it doesn't make sense, I would say, because you can release more often. It's not complicated. It's not quite big. But for larger systems, you would love it to have that when you start working on a product from the initial phase.
Thank you.
Any other questions?
How popular is toggle driven development?
It's very popular. The idea, where did I get this idea? I have a messenger application from Facebook, and I noticed that I didn't update my application, the version of the application, but I see new buttons appearing and disappearing during the working of the application, and I thought that how it's possible. I didn't update the application, but buttons or features are appearing and disappearing. And then I dived deep into these topics. And basically, Facebook is doing this, Instagram is doing this, Google is famous of doing chunk-based development. It's popular. Yeah. Yes.
How frequent you ship your software?
How quickly?
Yeah.
Okay. That depends on what software, and that quite depends on the product management as well. But if you have proper continuous integration and continuous delivery in place, you can ship even 3 times in a day if you want. Netflix is shipping like 4 or 5 times in a day. Yes, please.
So, as I understood, you work without branches with features.
Yeah, there is a single branch called trunk, and you push. Everyone pushes there.
How do you do code reviews?
Yeah, that's a good question. Again, let's talk about untrusted committers. If you have untrusted committers in the team, that's another different story. But if you have trust your people working on your software, pushing directly onto your repositories, the code review is just the social codes when you bring everyone together and to review with everyone. You can bulk commits together. Version control systems provide such ability, and you bulk commits together and for review purposes. Other questions?
What sort of testing do you do before going to production?
Yeah, that's also a good question. The first, developers should run unit tests locally before they check in. That's the first. And then comes the acceptance tests, functional tests, and end-to-end tests, and yeah, that's the chain of tests going on when you push your changes up to the remote. But developers always write the unit tests and they run tests locally before they check in. If you know GoCD, continuous delivery tool, it allows the developers to work locally, to check in locally before they can push to the remote. That's a very good feature.
Can the trunk be broken, or you block the commits that broke the trunk?
If it's broken, nobody else can check in. If you broke it, you should fix it.
You are not allowed to push that broken trunk, or you allow it?
No, if the trunk is broken, nobody else can check in until the builders fix
You're
it.
allowed to broke the trunk.
It's allowed to broke the trunk, but who broke the trunk is going to fix it.
But why you do the on the other way? So you try to before you run the test, you think the trunk, get it.
Yeah, of course, you run your test, you make sure that everything is okay, but when you check in, maybe 3 people before you checking in, and your change somehow doesn't work with them. You make sure it's working, you push that, and you understand that your changes are not integrated with everybody else's changes because you left 3 commits behind, for example. Cannot allow you to push if the
You are not up to date.
no. No,
No.
anyway you can push. Depends on the, if you run the tests and it's failing, you can also push. But it's going to break the trunk. It's not good. Other questions? Ah, thank you.